In this demo, we'll inspect our project's code structure. We've got just 4 files here. AppSettings.json contains application settings. Currently, there's not much in there, just some default log level configuration and allowed hosts. Then we have a controller with some dummy code. The weather forecast controller exposes weather forecasts. To allow for that, one supporting class has been added as well, the weather forecast class in the weather forecast file. It's this controller and related that ensured that we could get a list of weather forecasts in the previous demo from the documentation UI. I'm going to delete these 2. We're going to add our own controllers from scratch, as that allows us to better understand what's going on. The other class that remains is the program class. This is the starting point of our application, or to be more exact, the main method in this class is the starting point of our application. But there is no main method in this class. Especially if you're new to .NET 6 and C# 10, but have some experience with older .NET or C# versions, this might look a bit weird. There's no namespace, there's no class name, there's no method name even. That's quite unusual, right? Well, this is a new language feature named the top-level statements feature. We no longer have to manually write the class name and main method name in the program.cs file. The compiler will generate it from this. So know that the generated main method will contain the code we see on screen here. It's that generated main method that's responsible for configuring and running the application. In our case, we'll be running a web application, and that needs to be hosted. For that, a web application builder can be used, which is what results from calling into create builder. Once we have a builder, the services collection on that builder is what we can add services to while configuring them. This is the built-in dependency injection container. So by adding services to it, we can inject them wherever we need them in our code. Services should be seen as a broad concept. A service is a component that is intended for common consumption in an application. There's framework services like Identity, MVC, Entity Framework Core services, and so on. But there is also application services, which are application-specific and which we can add ourselves. Currently, there's only a few statements here. First is add controllers. This call registers services that are typically required when building APIs, like support for controllers, model binding, data annotations, and formatters. Don't worry if this doesn't sound familiar yet. We will look into the built-in dependency injection system in more detail later on. The other 2 statements, add endpoints API Explorer and add SwaggerGen, both have to do with the Swagger documentation we saw in the previous demo. These statements register the required services on the container that are needed by Swashbuckle's Swagger implementation. Once all these services have been registered and potentially configured, the web application can be built. This results in an object of type web application. Let's drill into this a bit. If you look at the web application class, we see that it implements the iApplication Builder interface. That's important to know because instances of classes that implement this interface provide mechanisms to configure an application's request pipeline, and that's exactly what we do next. By doing so, we specify how an ASP.NET Core application will respond to individual HTTP requests. The components that potentially handle these requests are called middleware. So that's what these use Swagger UI, use HTTPS redirection, and so on calls do. They build the application's request pipeline. Let's run our app. And just like before, let's navigate to the Swagger endpoint. So what we see is again the documentation of our API. There's no more weather forecast endpoint anymore, as we deleted that. What's important for us to know right now is that the fact that this documentation shows up is thanks to 1. The related services being configured and registered on the container, That's those add endpoints API Explorer and add Swagger gen statements. And 2, the related middleware being added to the request pipeline. That's the useSwagger and useSwagger UI statements. In this case, those ensure that a request to Swagger's index page will be handled by the code that generates the documentation UI. Let's clarify this a bit more by manipulating this. Currently, a few pieces of middleware are being added that will potentially result in documentation being shown, HTTP calls being redirected to HTTPS, authorization being set up, or mappings to other parts of our code being set up. But we have full control over this. What we could do is, for example, say that we simply want every request to write out "Hello World." So let's comment out everything in regards to the request pipeline, except for the actual app.run statement. Before that, we add a very simple statement, a request delegate to be exact, in which we state that we want to write out "Hello World." Let's give that a try. And let's try refreshing the Swagger index page. This time, "Hello World" is printed out on our screen, as that's how we configured HTTP requests to be handled. I can actually change this URL to anything else, as long as it's related to the application root. So, the application root gives me "Hello World." The application root /hello gives me "Hello World." And in fact, every other URI segment I add will also result in "Hello World" being written out. For your information, if you're completely new to ASP.NET Core, know that most of what I just covered in this clip also applies when you're not building an API, but a regular web application. The basics are covered in detail in the ASP.NET Core Fundamentals course here at Pluralsight. As far as we're concerned, let's continue with looking into the request pipeline in a bit more detail.